Today we can discuss the problem about the 2-bar truss problem with the finite element analysis. The problem is for the 2-bar truss shown in figure. In this figure, the node 1 to 2, the element 1 is available, and node 1 to 3, the element 2 is available. So both the structures are linked between the node 1 and the 2 is fixed point and the 3 is also fixed point. So in this problem they are asking about determine the displacement for node 1. What's the displacement by the node 1 is carried out, and the stress in element 1 to 3. So that second element stress also they are asking. In this problem, the point load 12 kilonewton is acted on node 1, which is also the figure has the data. After that, the Young's modulus of the material is 70 gigapascal and the area of the structure is 200 mm square. Likewise, the data are given in the problem. So, what are the given data? First step, we should collect the given data. First, they are given E is equal to 70 gigapascal. So, materials Young's modulus is equal to 70 gigapascal. We should convert this into SI units. So that how can I convert? Yes, gigapascal 70 into 10 power 9 pascal. First I convert. After that, how can I convert the pascal? Yes, 70 into 10 power 9 Newton per meter square. So again I may convert this meter into mm for solving the problem, because other data are available with the mm. So I convert this meter it into mm, so that the problem can be converted it into the mm square. So how can I convert? Yes, 70 into 10 power 3 Newton per mm square. This is a simple unit conversion. You should convert before starting the problem solution. So next we are having the area of the element, which is 200 mm square. Any other data? Yes, other data is point load, which is point load is also available with this structure, but this point load is acted on node 1. So the point load acted on node 1, which is equal to 12 kilonewton. So the 12 kilonewton is a large value. We convert that into Newton. So that 12 into 10 cube Newton. Likewise, we convert the units with the available problem data. After that, we slowly move to solve the problem. How do I solve the problem? Let's see. What are the formulas we utilized to solve this problem? Let's see. That in previous step, we are having the data with the diagram, which are the node 1 and node 2 has the distance of 500 mm, and node 1 and node 3 has the vertical distance 300 mm and the horizontal distance 400 mm. But we don't have the hypotenuse value, so that we consider the x direction horizontal and the y direction as the vertical. From this we can collect the data from the problem. So let's see what all the things we have to identify. Already we discussed, so that simply we move. So solution, consider node 1. According to our problem, node 1 is lying here. So consider node 1 as the origin, this point as the origin for our problem. So the coordinates, we should identify the coordinates of various nodes. Other nodes are 2 and 3. So we should identify clearly the node 1 coordinates and node 2 coordinates and node 3 coordinates. How? Let's see. So the solution is started from identifying the coordinates. For the reason, consider node 1 as the origin. So node 1 as the origin means, what about the coordinates of other nodes? Yes, coordinates made for node 1. What is the coordinate? I explained with the diagram. Yes, node 1 coordinates. Node 1 doesn't have any value because I consider this as the origin, so that node 1 is always 0, 0. So node 1 I can write as like 0, 0. Here first 0 is x1 and this 0 is y1. And node 2. What is the node 2 coordinate points? Let's see. Node 2 is like here. So in x-axis, the x-axis, this is one is origin, so that which is called as minus 500. So in x-axis there is minus 500, and y-axis there is no increment or decrement with y-axis, so that y-axis has 0. So node 2 points are minus 500, y-axis 0. And then we should identify the next node, which is 3. What happens node 3? Yes, node 3 points we can identify. The node 3 in x-axis 400 mm positive side, because then first node is the origin, so after first origin always positive, and beneath the first node it is negative y-axis, so that it is called as minus 300. So node 3 coordinates are plus 400 with x-axis and minus 300 in y-axis. So how can I write? Yes, let's see. Yeah, node 3 values can be written as like in x-axis 400 and y-axis minus 300. So node 2 has x2, y2, and node 3 has x3, y3. Likewise, we can collect the data for coordinate data for every nodes, which is the second step. After that, we can move to identify the length of first element. How do I identify the length of first element? The length of first element. What is the length of first element? How do I identify? For identifying the length of first element, we may utilize the formula, which is LE1 is equal to square root of x2 minus x1 square plus y2 minus y1 square. This is the formula. Is equal to square root of what is x2? According to our problem, x2 is minus 500. What is x1? 0. So minus 0 square plus what is y2? 0 and y1 also 0 square. So the square root of 500 square I got. So I can simply write 500 as the LE1. And then I can find the direction cosine for node 1. Direction cosine is the next step. So identifying the direct cosine, it can be utilized the formula L1 is equal to x2 minus x1 divided by LE1, which is the formula for Truss. So what is the x2 value? Minus 500, and what is x1? 0 divided by LE1 is equal to 500. So from this I can get 1. So direction cosine of L1 is equal to minus 1. And then what is the direction? Another direction cosine is M1. How do I identify the M1? Yes, M1 I can be identified from y value. So that y2 minus y1 divided by LE1. So what is y2? Just 0 minus 0 divided by LE1 500. So which is 0. So direction cosine L1 is equal to 0 and M1 is equal to 0. According to this formulas, we can identify the element once LE1 value and L1 and M1 value. Next we can move to identify the element 2. Okay, element 2 length. Okay, so for element 2, what are all the values for element 2 we are having? Yes, let's see. Element 2, which can be written as like Le2. The formula is for element 2 square root of x3 minus x1 square plus y3 minus y1 square. Why I wrote like this? Let's see. The element 2 has one node and 3 node. So the distance can be identified from x3 minus x1 and y3 minus y1. So that I wrote the formula as like x3 minus x1 square plus y3 minus y1 square. If I substitute the values, after all the values which has yes, I identify the x3 is 400, x1 is 0, y3 is minus 300, y1 is equal to 0. So I can easily identify the Le2. So how do I identify the Le2? Let's see. I can substitute the values. The x3 is 400, x1 is 0 square plus y3 is minus 300 and y1 is 0 whole square. From this, the aid of calculator, we can identify the Le2 is 500 mm. After that, we should identify the direction cosine for element 2. So direction cosines for element 2. For the reason I can write the formula L2 is equal to x3 minus x1 divided by Le2, which is the formula. What is the x3 value? Yes, we can refer. What is the x3? According to our problem, x3 is 400 and x1 is 0. From this, we can identify L2. So x3 is 400, x1 is 0. Then Le2 we are identified, which is 500. So 400 by 500. From this we can identify L2 is 0.8. With the aid of calculator, we can identify L2 is 0.2. And then we can identify the direction cosine for element 2. M2 is equal to y3 minus y1 divided by Le2, which is the formula. Here, what is y3? Let's see. In our previous slide, what is y3? y3 is minus 300 and y1 is 0. So I can substitute those values in our formula. So y3 is equal to minus 300 and y1 is 0 divided by Le2 is 500. So the M2 is, with the aid of calculator, I can identify minus 0.6, which is L2 and M2. So now we can move to identify the displacement of every elements. So first I want to identify the displacement for element 1. For the reason, we can move to identify the stiffness matrix, because we should identify the force. So for identifying the force, we need the stiffness matrix. From this we can identify the displacement and force values. For the reason, we can move to identify the stiffness matrix, because our problem has the formula of F, which is equal to stiffness matrix into displacement, which is a formula. So that next step we have to have move to identify the stiffness matrix. So what is the formula for stiffness matrix? Yes, the stiffness matrix for element 1, which can be called as K1, okay, which can be called as K1, can be identified through E1 divided by LE1. The formula is L 1 square to that L1 M1. Already we identified what are all the L values, L1 value and the M1 value, minus L1 M1. After that L1 M1 minus M1 square. After that minus L1 M1 minus M1 square, then minus L1 square minus L1 M1 L1 square L1 M1, which is the formula I rewrite. Already in previous video I told about how do we get this formula, and then L1 M1 minus M1 square L1 M1 M1 square. This is the stiffness matrix formula. In this, which is called as first column, second column, third column, fourth column. Similarly, first row, second row, third row, and fourth row. After that, what is area? According to our problem, what is area? Yes, let's see. In our problem, we are having the area value as like area is 200 mm square. So I can substitute that area value into our formula. So area is 200, and also what is the Young's modulus value? Already we found, which is 70 into 10 power 3 divided by LE1 we found, which is 500 into L1 square. L square already we found. What is L1? In previous step we identify the L1 values. Okay. L1 is equal to minus 1, M1 is equal to 0. So I can recall L1 is equal to minus 1 and M1 is equal to 0 again. So the L1 is equal to, in previous step we identified, isn't it? L1 is equal to minus 1 and M1 is equal to 0. So if I substitute here L1 square minus 1 square, which is equal to 1. What is L1 into M1? L1 minus 1 into 0, 0. After that minus L1. So minus L1, which is minus 1, and then minus L1 into M1, which is 0. After that the L1 M 0 minus M1 square 0, L1 M1 0, and then which is also 0. Here minus 1. I substituted value, that's all. L1 value and M1 value are substituted in the given matrix so that I can get these informations, and then 0, 0, 0. Likewise, I can get the values. So finally, I can substitute and get the K1 matrix, which is I place the calculator and identify this value as 28 into 10 cube, and then I rewrite the stiffness matrix values. 1 0 minus 1 0, after that 0 0 0 0 minus 1 0 1 0, then 0 0 0 0. Likewise, I can write from this for element 1 stiffness matrix I got, which can be kept as like 1, okay, because element 1 displacement matrix. After that we can move to element 2 stiffness matrix. So for element 2 stiffness matrix can be wrote like K2, which has the formulas like A2 E2 divided by Le2. Already we found what are all the values of Le2, and here the formula can be written as L2 square L2 into M2 minus L2 square and then minus L2 M2 and then L2 M2 M2 square and then minus L2 M2 and then minus M2 square and then minus L2 square minus L2 M2 L2 square and then L2 M2 and also here minus L2 M2 and then minus M2 square L2 M2 and then M2 square. Likewise we can write in previous I told about here minus L2 square, but refer in my previous slide minus L1. Okay, here also minus L1 square, so you consider here L1 square. For the reason if I substitute minus 1 I got the minus symbol, minus 1, not a plus 1, minus 1 I got from the previous step. Here I wrote correctly, which is minus L2 square. What happens here? What is L2 and M2 value? Yes, we found that from previous slide. What are all the L2 and M2 values? L2 is 0.8, M2 is minus 0.6. From this we can calculate the L2 is equal to 0.8 and M2 is equal to minus 0.6. So from this we can easily write K2 stiffness matrix. Already we know the A2 value is 200 and E2 is Young's modulus is 70 into 10 cube divided by Lu2 is 500. And what about L2? Already we found, so that we can easily write L2 square, 0.8 square is equal to 0.64 and then L2 into M2, 0.6 into 0.8 which is minus 0.48 and then minus 0.64 and then 0.48 then minus 0.48 0.36 0.48 minus 0.36 and minus 0.64 0.48 0.64 and then minus 0.48 and then 0.48 and then minus 0.36 and minus 0.48 and 0.36. Likewise we can frame the matrix. I just substitute in the place of L2 as 0.8 and in the place of M2 is minus 0.6. For the reason I may get these values, and then from this I can get the stiffness matrix of 2, which is K2. So if I simplify this term with my calculator, means I got 28 into 10 cube and I again write the same. Okay, so I again write the same thing with my paper. So which is our second step. Next step, this step is our the next is stiffness matrix equation. Again rewrite the same things. Okay, I rewrite the same elements that are available with the previous matrix. That's all. 0.36, 0.48, 0.36. This matrix is called as next equation, which is second. Okay, this equation is second. After that, I should assemble the both the equation, first equation and the equation 2. Okay, what happens? Let's see. This equation can be written as here also, because this matrix, stiffness matrix, is placed with the node 1 and 3. So the matrix here, the U4, U5, U6 acted, and here U1, U2 acted. I neglect U3, U4, so that 3, 4th term is not available with this, but 5, 6 available, because this U1 can be written as in this point U1, which is U2. Here I can write U3 and U4. In this point, third element, the elements are U5 and U6. So what happens? Let's see. In this I can write this is 1, which is second, but this is 5, this is 6th column, and this row is first row, this is second row, this is 5th row, and this is 6th row. Now we can move to next step. Yes, in this step, assemble first and second equation with each other means I can get. How do I assemble? Yes, in both the things I got common 22 in 10 into 10 power 3. Now I can assemble how 1, 2, 3, 4, 5, 6 columns I can rewrite. Okay, in first column, previous slide I can show you. In this first, which is the first column, second column, third column, fourth column, here also first row, second row, third row, fourth row. Here the first column has 1. Okay, what happens? Let's see. Here 1 available. What about the second equation? In the first, yes, 0.64 available. So how do I write? First 1 plus 0.64. Likewise I can write here the first element is 1. In this in first 0.64, so 1 plus 0.64. likewise I can write. Okay, so here I can write as like 1 plus 0.64 according to second column I add with each other. In second column 0 minus 0.48, you can refer again, and then minus 1 third, 3, 4 I neglected, so that minus 1, in fourth 0, but in fifth minus, I can recollect, minus 0.64 and then 0.48. same thing I perform, 0 minus 0.48. After that I compare the first equation and the second equation. I collect 0 plus 0.36, 0, 0.48, and then minus 0.36, and then other equations also I can recollect from those equations. Minus 1, 0, 1, 0, 0, 0, and then 0 0 0 0 0 0. After that minus 0.64 0.48 0 0 0.64 and then minus 0.64 and then 0.48 minus 0.36 0 0 minus 0.48 and 0.36. So assemble all the 6 rows and 6 columns with each other. From this I can found this new thing, okay, new stiffness matrix of assembling of first equation and second equation, which is our next step. With this step we can move to next step, which is what is the formula for finite element equation? Yes, F is equal to K into displacement. So now we found the K value with this step, so we can substitute those things with the finite element equation. What happens? Yes, see, I add 1 plus 0.64, so that 1.64, likewise I can write 0 minus 0.48, I can rewrite as like minus 0.48. Likewise I can rewrite and I can get the next step with the finite element equation. So let's see. So finite element equation is F is equal to K into displacement. So what I found the K value, yes, 28 into 10 cube, and then if I add the things I got 1.64 and minus 0.48 minus 1 0 minus 0.64 0.48 and then second row is 0.48 0.36 0 0 and then 0.48 minus 0.36 and then third row is minus 1 0 1 0 0 0 and the fourth row is 0 0 0 0 0 0 and the fifth row is minus 0.64 0.48 0 0 0.64 and minus 0.48 and the sixth row is minus 0.48 minus 0.36 0 0 minus 0.48 0.36. This is the stiffness matrix I got from the previous step. And then what is the displacement? I have the 6 degrees of freedom in our problem, so that U1, U2, U3, U4, U5 and U6. Here how do I told I have 6 degrees of freedom? In first step I told about yes, in this point U5, U6, here U1, U2, U3, U4, likewise the displacement acts. So U1, U2, U3, U4, U5, U6, likewise 6 degrees of freedom. Here you see U1, U2 available, U3, U4 available, U5, U6 available. So that 6 degrees of freedom acted in this problem. So I can easily tell the 6 degrees of freedom, so that 6 displacement acted. So U1, U2, U3, U4, U5, U6, likewise I presented here. After that, how many forces? I have 6 degrees of freedom. So 6 different forces acted: F1, F2, F3, F4, F5 and F6. So these 6 forces are acting. So I should find these 6 displacement, these 6 forces on the stress. In that the problem, according to our problem, the second node and the third node, those are fixed, but the first node is only free, so that u5 u6 are 0, u3 u4 are 0, but u1 and u2 only has the values. So other the displacement are not having any boundary conditions, because u1 have value, u2 have value, u3 is equal to 0, u4 is equal to 0, u5 is equal to 0, u6 is equal to 0. How I told yes, 3 and 2 are fixed, so that u3, u4, u5 and u6 are 0, because yes, so the boundary condition is changed. The boundary conditions, applying boundary condition is the next step. So applying boundary conditions, u1 is equal to u2 is equal to u4 is equal to, I mean u4, not u4, u5 is equal to u6 is equal to 0, because node 2 and node 3 are fixed. So this boundary condition I got. And in our problem, you see, in our problem, the force, the second node, I mean first node only has the point load which is 12 kilonewton. So a point load is 12 kilonewton is also acted on the body. In boundary conditions, I should consider about this force also. So the point load acted on the second element, so the F2 is equal to F1. How the F1 is acted? F1 is downward, so a point load acting at node 1 is downward direction, so F2 is equal to minus 12 into 10 cube Newton. Why I utilize here minus? Let's see. The point load acted at the downward position, so that I utilize the negative sign. So these two displacements are available. One is horizontal u1 and vertical u2, so that here I consider f2 only, not f1, f2 only. F2 is negative, F2 has negative symbol because the point load is downward, so that negative symbol I utilized. So now minus 12 into 10 cube Newton is acted. So what is our next step? Self weight is neglected. What about other elements? The self weight is neglected in the problem, so that F1, F2 has point load, F1, F3 and F4, F5 and F6 are 0, because self weight is neglected. Only one point load is acted on the body. So this equation can be rewrite as like the boundary, applying boundary condition, the u1, u2, u5, u6 are converted it into 0, and then the f1, f2, f3, f4, f5, f6 are converted it into 0, because the u3, u4 and sorry, I wrote wrongly here, u3, u4, u5, u6 are 0, okay, because node 2 and node 3 are fixed. Here you see in our problem, node 2, node 3 are fixed, so that u3, u4, u5, u6 are 0, but u1 and u2 has some value. I wrongly presented, sorry, now you may understand, okay. Here u3, u4, u5, u6 are 0, not u1, u2. So Here I can substitute u3 is equal to 0, u4 is equal to 0, u5 is equal to 0, u6 is equal to 0. Similarly, f2, f3, f4, f1, f3, f4, f5, f6 are 0. So I can rewrite the total equation again. Okay. Yes. How I collect the data from the previous slide. So 28 into 10 cube into matrix. I collect the information from the previous slide. 1.64 minus 0.48 minus 1 0 minus 0.64 0.48 into u1 u2 only available, other terms are 0. Force also f1 0, but f2 has minus 10 into minus 12 into 10 cube, other forces are 0. Likewise I can write. Okay, so I recollect the data only from the previous slide. So it consumes which is a huge matrix, isn't it? So that it consumes some more time. So you may also write with your notebook. 8 0 0 0.64 minus 0.48 and then minus 0.48 minus 0.36 minus 0.48 here 0.36. Likewise we have the matrix. Okay, now neglect second, third, fourth, fifth, sixth, because in this matrix 3, 4, 5, 6 are 0, so that I can neglect these rows and columns from the given equation. So I can rewrite the total terms. Here you see, according to force matrix, there is force 1, force 2 only available. Other force 3, force 4, force 5, force 6 are 0, and the displacement also 3, 4, 5, 6 are 0. So that I can neglect other terms from the equation. So I can write force the 0 minus 12 into 10 cube. So we can easily write, which is equal to 28 into 10 cube. After that I can consider only the first and second. 1.64 minus 0.48. Other terms I neglected. From these other terms are I neglected. So the second, which is minus 0.48, here 0.36, and here u1 u2 only I can rewrite. Now I can frame the equations. So the equations are the 28 into 10 cube. What happens? 1.64 into u1. So 28 into 10 cube, and then 1.64 into u1 minus 0.48 into u2. So minus 0.48 into u2, which is the matrix multiplication. After that again 28 into 10 cube. Then here you see minus 0.48 u1 available. First I multiply the things. So minus 0.48 u1 plus, here no negative symbol available, so that you can easily write the plus symbol. Here 0.36, here u2 available, so that plus 0.36 u2, which is equal to What is the force? Yes, yeah, force minus 12 into 10 cube. So likewise I can rewrite. Now if I simplify with the aid of algebraic formula, I can get the u1 and u2 value. How do I get? Yes, I can explain. I can consider this equation as the, because already we considered 4 equations, this equation as the 5th, this equation as the 6th. So if I multiply the 5th equation with the 6th equation, the 6th equation with respect to 6 means I can remove the terms. So 6th equation I can multiply with the 3.4116. I want to cancel the u1 terms from the available equation, so I can want to convert this 0.48 it into 1.64. How do I convert this 0.48 it into 1.64? If I multiply 0.48 with 3.4166 means I can get 1.64 here. So I can easily remove the u1 term from the equation, so that I can multiply 6th equation with 0.3116. So I can multiply the 6th equation into 3.4166. From this I can get as like 28 into 10 power 5, because I multiplied with 3.4166, so that here 28 into 10 cube, 10 cube, it into 1.64 u1 minus 0.48 u2 is equal to 0. And then 5th equation I can rewrite the same, 28 into 10 cube to minus 1.64 u1 plus 1.23 u2, so minus 41.10 cube. Likewise I got. After that I can easily remove this item from this total equation. From this I can get with the aid of calculator u2 is equal to minus 1.952 mm. So u2 is equal to minus 1.952 mm I got. After that I substitute this u2 value in equation 5. I can get the u1 value is 0.571 mm. Next step is important. How do I identify the stress value on element 2? I simply tell and I can leave. Okay, the stress identification formula. Stress can be identified sigma is equal to E divided by LE into minus L minus M L M into U1, U2, U3, U4, which is the formula for identifying the stress. So for element 2, the problem has the question about element 2 stress. So element 2 stress sigma 2 is equal to E2 divided by LE2. After that minus L2 minus M2 L2 M2, and the displacement according to element 2 U1 U2. After that U5 and U6 you consider because element 2. So if I substitute all the values I can get the final answer. What is E2? 70 into 10 cube. LE2 is 500 and L2 is minus 0.8, M2 is minus 0.6. So here 0.6, 0.8 minus 0.6 and U1 is minus 0.571 and minus 1.95200. Which is the equation. From this I can get the sigma 2 value with the aid of calculator is minus 100 Newton per mm square. Okay, which is answer. Why I got minus? If the minus is acted, the stress is compressive. So in this problem, compressive stress acted. Likewise, we can identify the problem answer. Now we identify what is our problem stress, and also I identified the displacement with the node 1 and node 2. Node 1 0.571 and node 2 minus 1.952 mm. I found this is the procedure to solve the problem. Thank you all.